All right, so let's go ahead and continue on with Chapter 4. This is part 2 of the requirements modeling section. And we've talked about the modeling methods, JAD, RAG, agile methods. Now let's look more at the tools and the techniques that we can use inside those methods. So we're going to start with what's called an FDD, a functional decomposition diagram. And the one we're looking at is based on a business called Liberty Management. Okay, so it's similar to an organizational chart. In this case, we're looking at the functional levels of the business. So, Liberty Management is basically made up of a human resources, finance and accounting, an operations division, fundraising, and new user acquisition. So those are, let's call that sales, right? New user acquisition, sales and marketing. If we then explode the library operations part, we'll see that under there's operations budgeting, there is book management and personal assignment. And under book management are these processes of adding and removing books, checking out and returning books, archiving checkout list and user list, user updates, and report generation. So you get the idea based on an organizational chart. So we could easily create this in Microsoft Word using SmartArt, for example. So let's go ahead and continue on. So business process modeling, or BPM, is the idea that we start to graphically represent the processes that make up a business. Okay, so if we look at McDonald's, I don't know why I'm so focused on McDonald's lately, but if we look at McDonald's, they have many business processes. Process order, what does that entail? So here, an order processing system would have two processes, one for an existing customer, one for a new customer, because of course with a new customer, we need more information. We want more information. We want to be able to garner all that information that we can then use to market to them. So you get the idea here. Let's move on. So here we're looking at a data flow diagram, and we're going to spend some time with DFDs this week in the homework. So a data flow diagram is essentially what we're looking at here, okay, is a black box. We don't know how it happens. We just know things happen in here. So as we level these down, we're going to get down to a level that's called the functional primitive. And that means there's no functions below that. So if we start thinking about just a basic accounting system, and we start with a context diagram of zero, that context zero diagram that represents, it just says the accounting system, or in the case of personal trainer, it would say personal trainer's system that you're going to be looking at designing. So if you notice here, things come into and out of the process. Okay, so in this case, add new books. Well, add new books, and then if you notice, remove books. So these two processes together have been exploded from a process 1.0 at the level above, okay, that could be called add and remove books. So if you notice, we start breaking down all of the function within the system and diagramming it. So another model is the use case diagram. So the use case, I like use cases. This basically becomes the border of the system. So we have to have this border. And this is the sales system. Well, inside the sales system, we're going to look at just one single process called the validate credit card process. Okay? And so if you notice here, they have an actor, someone that sits outside of the system. They're not part of the system, but they interact. That's how I remember to call them actors. They interact with the system. So the customer is going to submit, that's the process, credit card data. And then we're going to have a process inside our system that validates that. So as we draw a diagram, we also get some detail that goes along with the diagram. So we name the use case. Now, a good name for a use case is going to be what the use case does. So in this case, it's the credit card validation process. Well, the actor is going to be the customer. They're going to be the ones that submit the credit card information. So it describes the credit card validation process. That's the description. There's a successful completion. We can call this the true. Okay, so if during successful completion, the customer is going to click the input selector, they're going to enter the credit card. we're going to verify the credit card, and then the system sends authorization message saying, okay, you're authorized. Well, perhaps they gave us the wrong credit card information. Perhaps it's a credit card that has been blocked or locked because it's been lost or stolen, those kind of things. So we definitely play and take a look at that. So anyway, so the alternative, customer clicks the input selector and enters credit card number and expiration date. So system rejects the card. This time we send a rejection method. So the precondition, of course, is that the customer, in order to go through the validate credit card, they have to have placed an order, say in a shopping cart, okay? And the post condition being, we validate and the customer is able to continue with their order. So just in itself, this is a nice graphical representation of this process. Now, we might find other processes where many actors, let's say, for example, we have someone who we have a process or many processes inside a system for ordering parts for a work order. Okay, so the work order manager would write up the work order based on what? Based on the customer input. So the customer and the person writing it up are each going to be part of the compose work order. That work order is then going to go to somebody who orders the parts, someone else that might schedule it, and we can start seeing that breakdown of the different functional components that make up a subsystem called process work order. Okay, at the end, we'd complete the work order. We might assign it to, say, a mechanic. They'd complete it. We would bill it. You get the idea. So sequence diagrams show the timing and interactions between objects as they occur. So we had that customer, right, credit card authorization. So the customer is going to do something. They're going to enter the credit card information. A process will validate it. And if it validates, it'll do one thing, validate or verify the credit card, and then give authorization, right? So in this, we'd have two processes, one if it verifies and another if it doesn't. So system requirements checklist, output examples. As we do the requirements, of course, why are we putting all this information into a system? We're putting it in. We're putting data in to ask questions of the data to get information that we can use in business to make fact-based decisions on the data that we have. So hopefully that makes sense. Now, output examples. So the website must report online volume statistics every 4 hours and hourly during peak periods. So consequently, we want to know every 4 hours and then during peak periods, every hour, what kind of volume's going through this website. So this is information that Amazon, for example, would want to know. Why? So that they know if the system's able to handle it. What are people ordering, etc. So the inventory system must produce a daily report showing the part number, description, quantity on hand, quantity allocated, quantity. So quantity allocated would mean we've already allocated a portion of our inventory into, say, a manufacturing work order, for example. Quantity available, which means how many are not allocated. That's pretty simple. And unit costs of all sorted by part number. So we're looking at part numbers. Well, we might also include things like, are there any parts on order? So we know some are coming in. We just may not, and we may have a delivery date. So the contact management system must generate a daily reminder list for all sales reps. So you're getting the idea of outputs. Now, today, when we talk about output, the traditional output just a while ago was, gee, we're going to print a report. Well, what do you want to do? Print a report. How do we get this information? Print a report. But today, we want to display that information in all different forms. It may come in on our smartphone as a dashboard that's updated. I hit the update button and it goes out and asks questions of the system and gives me the latest information. How many parts have we produced this hour? What's our defect rate for that? So we try to, and again, get that information to the people that need it. So a lot of times, a great example is when I did my master's over in China. I did a consulting for a manufacturing firm, and they would actually deliver the data to large screens throughout the manufacturing plant so that users, people who were creating and manufacturing the parts, could go up and basically hit a touch screen, update, and figure out what their current defect rate is, or what lines were up or what lines were down. So the information was delivered in real time. And if things changed based on some thresholds set, data might come up in bright red, or it might flash on the screen, hey, we have a problem. We have a manufacturing cell that's down. And engineers would go figure out why so that they could reduce that downtime. So input examples, well, input comes from everywhere these days. It's not just someone sitting at a computer entering data. Today, we might get input from other websites who we're marketing with, so click-throughs and data of that caliber. Employees, most employees now have a badge of some sort that they're using not only to monitor their time, but also their processes. So as they complete a process, they swipe their badge, or they hit a button, whatever the case may be, all the way up to opening doors. So the same badge can be used to secure areas within the plant, all of which is data that we're going to want. So department head must enter overtime hours on a separate screen. So if people have overtime hours, we don't want to accidentally put it on our regular hours. And we don't want just anyone doing that. So a supervisor needs to come over and supervise and say, yep, you indeed work 3 hours overtime. Let me put that into the system. So students' grades must be entered on a machine. Scannable forms prepared by the instructor. Scantrons still exist today. It's amazing. It's basically like dropping it through a machine, and by the time it hits the bottom, it's already been scanned. It's amazing how we've improved data input. So date, time, product code, you name it. Barcodes. Think about stores and barcodes and the data that flows through a grocery store, for example. So process examples. So we're looking at all the different components of a system. So the process, student record system must calculate the GPA at the end of each semester. So when we finally close out, when all the final grades have been put in, there we go, we put that in. As the final step in a year-end process, so payroll system must update employee salaries, bonuses, benefits, produce the tax data, maybe ship out those 1099s, for example. So when we close the year, there's a bunch of accounting process that can be automated once we close the year. So, warehouse distribution system, you get the idea. We don't need to go through all of these. You can pause if you'd like and review other processes. So what I'd ask you to do is just think about driving a modern car today and the processes that go along with driving that car. Connecting the Bluetooth to your phone so you can play music off your phone or Spotify through the audio system in your car. So performance examples. So of course this is huge, right? We certainly imagine going out to Amazon to place an order and it says, yeah, you just hit the submit button. Now you need to wait 5 minutes while we process your order. Nobody's going to wait around, right? This is the web. It's instant gratification. We want it yesterday. So I need to be able to order it today and ship it overnight for free, for example. So here, though, we're talking about realistic performance examples. So a system must support 25 users online simultaneously. Well, let's look at Facebook. What do you think their performance examples are? How quickly a user logs in, how quickly they get to things, how quick updates, update their page, that kind of thing. So when one of your friends texts you and says, hey, I just updated my Facebook, you hit refresh and boom, there's the data, right? You don't want to hear that they updated it and 2 days later you finally get the update. We wouldn't stay on Facebook, for example. So response time, a lot of times when we're talking about performance, it is in support of users. It's in support of processing X amount of data. Performance example, go out, just pause the video for a second, go out to YouTube and ask YouTube how many terabytes of video are uploaded to YouTube a day. It's an amazing number. And look how fast my video, for example, this presentation here, I'll upload it to YouTube, and within minutes, they've processed a multiple minute video that's done in high definition, that's done in stereo, and boom, it's available to the world. That's the kind of process and performance we're looking at. Today, performance becomes way more important than it used to be because people aren't willing to wait. I don't know how many of you have a solid state computer with a solid state drive, but right now as I do this, I'm working on a solid state computer and I'm backing up an old computer with a SATA drive in it. And the same amount of data to back that computer up, oh man, 45 minutes to an hour. Backing up my computer, which is solid state, to a solid state, I can back up 500, 600 gigabytes in about 3 to 5 minutes. It's just amazing how quick the technology has gotten. So let's move on to control examples. So the system must provide logon security at the operating level and at the application level. An employee record must be added, changed, or deleted only by a member of the Human Resources Department. So that person is going to be given the access to make the change. Now, notice it says added, changed, or deleted. It didn't say read. So maybe everyone in the organization, or in this case, it's human resource. So the only person we'd want to have read that would be other people in the human resources department that don't have the add, changed, or deleted process. Managers may need to review a HR file of an employee, and an employee may need to make changes to an HR file. Of course, we wouldn't want other employees seeing your HR file, of course. So there's another example of control. Only the employee can see that employee's HR file unless they've been elevated control as a supervisor to then see all of the employees in the department over which they supervise. So scalability, this one's definitely huge. I don't know if you've ever seen the commercial. There was a commercial on a while ago where, a group of young people started an online business and it must be opening day and click, there's an order, and they're ecstatic. They're like, yay, wow, we just came up and we have our first order, and then boom, here's another one, and boom, 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 here's another one, and pretty soon they're looking at 50 orders and they're ecstatic. You can tell it's gone past their wildest dreams, but then suddenly it continues to click. Click, 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 and now they're at hundreds and thousands of orders, and suddenly it goes from ecstatic to, oh my gosh, what are we going to do? That's scalability. So imagine with scalability, if Facebook wasn't designed the way it was, and it didn't scale well, it didn't scale out from colleges to people to regions to countries, would we use it if it wasn't scalable? So today, as we build systems, we may be thinking, okay, well, the current business has 200 employees. All 200 employees, 150 of them are going to need to be able to log in and use the system concurrently, so at one time, right? But then what happens if the business suddenly expands and we didn't design the system to support 1,000 employees? Well, we suddenly become a bottleneck to the productivity of the business. So everything needs to scale. The outputs, the inputs, the process. We need to look at scalability. This, by the way, is one of the reasons why folks are looking at building applications via the web. Because when we store those in data centers, we can actually then dynamically scale, add more resources, add more memory, add more processing power, add more disk space, literally dynamically as the system needs to grow. Only, however, if the system has been designed to support that scalability. So, what does all this result in? Well, as we build a system or buy a system, the system has a total cost of ownership, and that total cost of ownership is essentially the tangible and intangible expenses while the system is usable. Okay? So consequently, if you've heard the term depreciation, when we purchase an asset, we choose a point and we depreciate its value. Okay? So that's sort of like the reverse of total cost of ownership. Let me give you an example of total cost of ownership. So let's say we go out and we buy a brand new Tesla Model 3, which is an all-electric car, not yet out, but we're going to say it's out. And we know that the car is $35,000 flat. Okay, so we paid $35,000 for the car. Well, there's no gas, but the electricity bill in our house is going to go up, So we need to calculate how much electricity we're going to have to purchase to operate the car. Then there's the fact of wear and tear. Maybe it has a warranty, so for 2 years everything is covered. 2 years, 24,000 miles, everything is covered. But after that, suddenly, well, the battery pack only lasts 4 years. We plan on owning the car for 6 years. Our software development life cycle, or our life cycle of that car, we're saying is 7 years. So consequently, we need to include that battery pack, replacing that battery pack. That becomes total cost of ownership. Well, that's going to require someone with the technology and the skills to put that in. Boom, there's some mechanical costs. You get the idea. That's total cost of ownership. Oh, look, we need to put new tires on it, new brakes on it. Just because it's a electric car doesn't mean the brakes don't wear out and the tires don't wear out. Great, we have those expenses too. So those are all, that would be really easy to figure out. That's tangible. What becomes really difficult is when we have a system, and one of the benefits that we expect to gain from the system is a 10% increase in our customer base. Great. Can we really measure that? Well, of course we could by saying the day before we put up the system, we have, 500 clients. And 60 days into the new system, we suddenly have 550. Okay, we've met that. But see, that's not tangible. Those 50 clients may or may not buy the average, amount that our previous clients bought, for example. So intangible, it's going to increase our customer satisfaction. Well, how do we measure that tangibly? We may just simply say, okay, we're going to send out a survey and, we have 4 out of 5 stars and we're looking for 4.25 stars over the next 6 months of implementing this new system. Well, if we reach the 4.25 stars, we've reached our goal, but that's not tangible, right? It's an intangible. So the same thing holds true with total cost of ownership. We have to look at, with systems, the cost of the server, the cost of the maintenance, the cost of downtime. So let's say that server, we can say, normally handles 1,000 orders an hour, and it's down for 3 hours. We just lost 2,000 orders that aren't going to be placed. That becomes a cost in the total cost of ownership of the system. So an unexpected cost, granted. So back a little bit more to fact finding. Fact finding. So first, you must identify the information you need and develop a fact finding plan. Well, that makes sense. Now, when we start looking for facts, we ask those questions that I've challenged you to focus on. Who, what, where, when, how, and why. So the difference between asking what is being done and what could or should be done. We want to be careful when we're doing fact finding not to ask leading questions. So let me give you an example of that. One question we might ask students is, would you prefer an 8-week or 10-week summer term? So see, that's an open question versus saying, if we only offered a 10-week summer term, would you still take summer term classes? Are we going to get a very different response from the same group of respondents? Of course we are. One question is leading. It doesn't give an opportunity for something to be different or an alternative, if that makes sense. So typical questions to ask: what business functions are supported by the current system? What strategic objectives are we trying to meet? What's our current vision? What's our current goal? What's our short-term goals and our long-term goals for the company? How does this system that we're going to design enhance and meet those goals? So, must the new system interface with a legacy system? So a lot of times up at COCC, we have a legacy system called Banner. Well, we've had to build a web-based interface so that you can register classes online. We're building a system over a legacy system. And the problem with that is, what happens if the legacy system goes down? How much have we built on top of that foundation that could then crumble as well? So typical questions, more typical questions, what security issues? And security today, we need to focus on security. Are we encrypting data in our database? Believe it or not, we used to put everything in a database and there was no encryption. But now we want to encrypt data that if stolen, we know it's protected because you're not going to be able to get into it even if you stole the database, you're not going to get that key information. Great example today, Samsung Android, the new Marshmallow version of Android, all new phones. So if you're upgrading your phone, this doesn't apply. But all new manufactured phones are going to come with 128-bit AES encryption on all the data on the phone. So there's an example of us focusing on encryption. You might be aware of the Apple versus FBI case. That's all around encryption because supposedly the FBI couldn't break in. We now know they're now in. So fact finding out, go ahead and pause this and read this. The who, the what, the where, the when, the how. These are questions we want to continue to ask in order to be a great systems analyst. So who does what is done, where is it done, when is it done, how is it done? So who needs the information? What information do they need? Well, where do they need the information? Do they need it via a web-based interface? Do they need it on their phone? When do they need the information? And how do they need the information? So you get the idea. So a little bit more, Zachman framework for enterprise architecture helps managers and users understand model and assures that overall business goals translate into successful IT projects. So do a little bit of research on the Zachman framework. You get the idea that we're always back supporting business. That's the key there. So interviews. Interviews are a great way to get information. First of all, let's realize they are costly. They take a lot of time. Focus groups might be a way to cut that cost where we interview as a group. The challenge with that is we don't tend to get truly independent opinions because people are worried about, well, what if I say the wrong thing in front of this group? Are people going to laugh at me? You get the idea. So here's a basic 7-step process. We determine who we're going to interview, establish the objectives for the interview. What are we trying to gain? Develop interview questions. By the way, we might cycle through this to finally get some good interview questions. We might even do some beta test interviews to see if our interviewees understand our questions. Once we do that, we prepare for the interview, we conduct the interview, we document it, and then we evaluate the results of the interview. So, realize as we do this, we have to look at the person we're interviewing and saying, okay, are they really giving us the answers we want or the answers they want to give? Those are two very different things. People might come in and say, well, I know what my manager wants me to tell him, so that's what I'm going to tell him. Anyway, you get the idea. So interviews, determine the people to interview. You can go through this. Go ahead and pause. So I'll stay a minute on here. I'll stay a minute on step 3, so developing interview questions. Let me just quickly say, when we're talking about personal trainer, we don't care about customer satisfaction. We want questions that pertain directly to the system that we've been hired to build. Okay? So we don't need to know, what we need to know is, would the users use a mobile app if it was available? Would they pay their bill online if we made that available through the new system? Those kind of things. Well, do you like the fact that you can work out from 8 to 4? How does that apply to our system? It doesn't. So remember, we're not worried about customer satisfaction and the satisfaction of personal trainers' customers. We're worried about questions that will give us the information on how to query them to see what functionality they want in the new system. What functionality does personal trainer employees want? Does top management want? You get the idea. There's step 4. We prepare for the interview. Again, going ahead and pause this. Step 5, the interviews. So if you notice, we start to schedule the interviews. Make sure, by the way, people aren't rushed. Make sure you have a comfortable, and also make sure you assess the person you're interviewing. Because if it seems like, wow, they're jittery, they're in a hurry, they're really not participating, you can actually set some values, some point values on the results they give you versus someone who was engaged, who prepared for the interview. Maybe you gave them sample questions like here. Conduct the interview, develop the specific plan for the meeting, document the interview, and finally evaluate the interview. Are you going to have unsuccessful interviews? Sure you are. You can pretty much start to gauge folks and say, yeah, that didn't go as I expected it to go. Maybe you even throw out the results that you're given there. Okay, now you don't make that decision. A group of folks, again, evaluating, would make that decision. So document the review. Observation is another way for fact finding. Now, observation is really interesting. Seeing the system in action gives you additional perspective. Seeing people work with the system can give you a perspective. I remember observing a system. I went, well, why are you going from that screen and then you're clicking 5 times to go to this screen? Well, because the form that we have changed, and the form that we have to use now has this part of the information that I fill out on screen 1. Then I got to jump to screen 6 because that's the next information on the form, and then I jump back to screen 2. Well, that tells us there's an opportunity for process improvement. Okay, so hopefully that makes sense. I would ask you to review the Hawthorne effect. What was it? Well, productivity seemed to improve whenever workers knew they were being observed. It didn't matter in the Hawthorne studies what we did. Made it colder, they worked faster. Made it hotter, they worked faster. Did this, they worked faster. Took away tools, they worked faster. Why? Because they were being observed. They were being paid attention to. They were being asked questions. They felt important. They felt included. Keep that in mind. Think about those Hawthorne effects as you work on your first project, for example, doing project management. So questions for the survey, my thing is keep surveys short and simple. There is a reason a lot of companies will say, hey, we've got this short survey, go online, fill it out. They know you're only probably going to fill out the first 10 questions before you get bored. Every time you notice you're clicking the submit button, they're getting the answer. And then they'll let you write as long as you want. So you just continue to fill it out. Keep it brief and user-friendly. So sometimes we may do a short survey that may actually lead to coming back and asking more questions on a survey. Okay, we sometimes have to entice people to fill out surveys. If it's customers, give them something, the opportunity to win a $50, Amazon card, etc. So read through these other fact-finding techniques. There's a ton of great fact-finding out there. Don't forget there's this thing called the web. So different kinds of sampling that we can do. Systematic samples. Select every 10th customer for review. All right? Stratified samples. Select 5 customers from each of 4 postal codes. Well, in Personal Trainer, we're definitely going to want to do a stratified sample. We're going to want to sample customers. Okay, we might use a systematic sample inside of a stratified sample, meaning systematic. We're going to try to sample every 5th customer that comes through the door every hour, for example. So we're going to do surveys throughout the day. Why throughout the day? Because we've got people that work out in the morning. That's a completely different demographic than the retired folks who come in the afternoon when the gym isn't full. That's a completely different demographic than the folks who come in January and are gone in February. You get the idea. We want to get a good sample. A great sample would be 10%, of our total population. So if we have 500 at each location, 500 customers at each location, we want to be looking at, 50 from each location. Why do we need to do it at each location? Maybe one Personal Trainer location is downtown. We're going to pick up professional people there. They're apt to use their smartphone apps, etc. The next location happens to sit in a large area of retirement communities, and thus that's a completely different demographic. And we want to know, well, they're not going to use the smartphone app. Heck, they're not even going to log onto the web. So you get the idea. We want to make sure, because we might find out that our demographic just simply won't use certain functionalities in an app. Why do we want to spend the money and invest in development? Get the idea? So, and then a random sample as well. So research can include the internet, IT magazines, books to obtain, background. You're definitely going to start your research on your personal trainer project via the web, clearly. There's also things like professional organizations, the National Organization of Avionics Manufacturers. So that's where we all come together and start sharing some data, or we ask that support mechanism to do surveys for us so that it doesn't seem like our company is looking for the data. We're looking for data as an industry. Okay, so of course we get different results. Interviews versus questionnaires, brainstorming, structured brainstorming, unstructured brainstorming. Look up brainstorming. Figure out what that is. It's a great technique. It builds that creativity, for example. At the end, of course, we need to record the facts, record the information. A great way to record survey results, Excel, because that way we can go create charts and graphs and ask information of the data. So hopefully you get that idea. Documentation, well, look there. I just was one frame ahead or one slide ahead. Spreadsheets are great. Database management, if we're talking about large amounts of data. Back into presentation software, those charts and graphs, so that we can present our findings out to management, to figure out if we move forward. Process, Visio is a great process demonstrator, in the aspect of, here's a business process, here's how it works. Somebody's going to get parts, they're going to put them together, somebody's going to, manufacture it and finally ship it. So you get the ideas. We're getting close to the end here, folks. Hang on. Information management software. So, personal data management. Outlook, we all know what that is. Outlook is a place for us to manage our time, manage our primary communications, task lists, you name it. Calendars for groups, all in one suite of applications. So, preview the logical modeling. At the conclusion of the requirements gathering, system developers should have a clear understanding of the business process and the system requirements. So realize it's not just about interviews. It's about going into the old system, seeing how the process was done, interviewing, well, what do you like? What don't you like? What needs to be improved? What are some opportunities for growth and scalability? All those good things. So be careful. IT professionals do have different views about systems development methodologies, and no universally accepted approach exists. A lot of times we're going to use what we've learned in one system to apply to another. We find the best of both worlds for our organization. All right, so that's it. This was kind of a long video. Hopefully you stuck in there. Take care. We'll talk soon.